Hi, this is Steven from the Green Engineers, and welcome to February 16th. This is an update of the Reclaimer shredder, plastic shredder. So we have me and Kevin. Kevin's here. This is his first video here on the Green Engineers. I'll go to him in a second. But we've added the motor here. This is a Chicago Electric, and we'll talk about that after I talk to Kevin. So this is Kevin.
Yeah, hi guys. My name's Kevin. I'm a junior at a local university, majored in electrical engineering, and I'm just here helping and learning from Steven about the Green Engineers project.
Yeah, so Kevin here is helping me in exchange for a little bit of hands-on experience, and also keeping me motivated on getting these projects finished and in use all over the world. So we were able to make a whole lot of progress going forward. So let's go ahead and start on this side. So this is a Chicago Electric spade drill motor. It's supposed to have a 600 RPM output, and it's supposed to be 7 amps, 110, 120 volts. So it should be about 1 1/4 to 1 1/8 horsepower motor. And again, 600 RPM output theoretically. And I have over there the blue bag. That is a non-contact RPM meter. Kevin's grabbing that now. He's going to open that. And so we have some tape here to read the RPM. So here's the meter here, non-contact. And so we actually were measuring that at low speed. The bare minimum speed that this guy could run at is about 300, about 331. And as you can see, we have a big gear here. So we have a gear ratio from a small gear to a large gear. The large gear is about a 54 tooth, and the small gear I think is like a 8 or a 10 tooth. And this gear is about 1.5 inches. This gear is 11.5. So I think it's something like a 8 or 9 gear ratio to 1. So here, this one is about 331 RPM measured, and this guy is about 50 RPM measured. So we're looking at only about a 6 or about a 6 to 1 output because of probably friction and things like that. So we're losing a little bit of well, no, it should be pretty much directional. The only thing you'll lose is power. So I think that meter is slightly off on this side because this is really shiny on the steel. So if I paint some of these guys and then put the tape back on, I should get it, or even Sharpie it. Even if I just go in and I Sharpie it, I'll get a pretty good reading. But the ideal case is if I had something like a 10 or 12 to 1 gear ratio here on this big gear. This gear again is 11.5 inches from tip to tip, and the contact point is I think 11 1/4 or 11.1/8 inch is the contact point. And this gear, let me show you by unscrewing this. This is the nut that we're using for right now, because we're actually using the chuck off of it. And these my buddy water jetted for me. Thanks, Parnell. And I gave him a little bit extra slack because I didn't know how good of a tolerance his water jet could cut. He has a little Omax Protomax water jet. So I gave him a little bit of extra tolerance so I could measure it and then be able to, when I get another tooth made or another gear set made, then I could tell him exactly. So this one also, as you can see, has some tolerance on it as well. So this is pretty cool design. It has this opening here for the drill motor, and the drill motor actually has this opening here. And this is a brushed gear motor. So it goes on really nice there, and then you just spin the chuck back on it to hold the gear on there. And eventually, like I said, I think in past videos, this guy will eventually have a hole here and a bolt on here to hold this guy on, and then there will be something back here to hold this on. So me and Kevin have moved the gears to the back, the synchronization gears, to synchronize both sides of the shredder, and so that way we can rotate on this side. Because we were a little bit out of alignment here for whatever reason. We shouldn't have been, but we were. So we flipped the gear onto this side. Now we're in good alignment. And then we had this motor flipped, and it actually had a gap here. And then I realized I actually designed the motor to be in this position. So we had to re-drill some holes. And because of that, the spade drill has 3 holes for the handle. There's actually a handle that goes on there. There's one here, one on the bottom, and then now there's one on the front. It used to be on the top here. And so now that's the issue that we're having, is you can see that it's actually pivoting on those 2 bolts. So we need something here to keep it from pivoting that way. It would even it would even work if we had one here and one here. So we're going to need to do that. And as you see, these are just 2 1/4-inch plates, one here and then one below, and it's basically on like skis. And then this is a piece of tubing, and there's the other piece of tubing there. So this is a piece of tubing cut, and then you cut the handle off of the drill motor and you shave it a little bit. You shave the metal a little bit so it slides right in there, and then you drill some holes, and then you could put an M14 by 2 bolt in there, and then that's what goes inside and that's what fits. And then you have all the electronics here. They are exposed. Eventually we are going to cover those up, and we're going to do something different than this kind of trigger. Eventually there will be a safety back here that me and Kevin are working on, where it requires both thumbs to press down on 2 capacitive touch buttons in order for the motor to turn on. It will also have over-amping safety, so that if you over-amp, it'll just rotate backwards and kick out the plastic. So I'm going to go ahead and switch here with Kevin. I'll show you what we were able to do here today. So we were able to shred a couple of different stuff here. So we were able to shred some PLA parts. So these are some X-printed parts. And also we were able to shred some water bottles. So what we've found is that it's way better at crushing than it is as cutting. It is a great crusher, and it just eats the plastic. But what I've also found is that I believe it needs additional down gearing. Either additional down gearing or a higher powered motor. So I think if this motor was about like a 2 horsepower or maybe 2.5 horsepower, or if this gear motor was bigger, because again, this output, so here would be your input and then this would be your output. If this output was bigger and I had a bigger ratio, then that would also help. So if I move this motor back to its normal position where the shaft was about here, I could probably go another inch or so on this gear. But then I would have to have my buddy mill it, because it won't fit on his water jet. So that's another possibility, is to get an even bigger motor to fit on there. I do like the gear here, because it's very symmetrical and it has plenty of meat on it. So you can see here it's very symmetrical and it has a lot of meat on either side. So I really like the design of this. Can you do that, Kevin? Thank you. So I think that that's a very good design for that particular gear. So we'll probably keep that, but we might go bigger on this gear. But the issue with that is that it won't fit to ship it, because the max that we can fit in a box is 12 inches. And also, what else? So that will get us closer to, my desired would be 15 RPM would be great. Right now we're at 50 at low speed, but I think if we get it down to 15, and that is barely where it just turns on, it's at 15. I mean, sorry, it's at 50. So if we could get that down even further, cut that in half, so 25. But if we cut that in half, that means that this would have to double in size. Obviously, that's not going to happen. And then you can see we have a little bit of forward and backward backlash. So yeah, these are the shavings that came out of it. So we can get it to shred, but it does beat on the motor pretty badly. So we also have some slight bolt misalignment, so that's why we have a clamp here. And we have it set up so that we could show you it running a little bit. It's got some plastic in there already from being shredded. So go ahead and, Kevin, go ahead and bump it. As slow as you can go, there you go. So here you can see gears on the back. And here's the front. And you can see these guys popping up and down. So I think that if this was even slower, I think we would be in perfect shape and we would have plenty of power. So if we could bump this motor size up to about 1.5 horsepower, and if we could drop this gear motor down and we had this kind of output speed, Kevin's going slow on the output speed, it could go way faster than that. But I think that this is controllable. So this is what I would suggest here, this kind of speed. But like I said, even more gear down where we're about 15 RPM. But we're making progress, so we might redo this gear and try to get even more out of this motor, or we might try to find a new motor. So if we flip this around, we could keep this motor from rocking, and also we could put bigger gear on it. So that's the idea. Flip this over, put a bigger gear, and then we might be able to get a little bit slower, a little bit more power, but it'd be nice to have a bigger motor. But I do like how this sits. So that's it. Alright, thanks guys for watching. Stay tuned for the next update from me and Kevin, and we'll see you guys in the next update. Thanks for watching.